All right, yesterday we talked about acids. Today we're going to talk about bases. And so acids and bases are opposites of one another. And bases, you will find out that in a lot of places, people, instead of calling them bases, they will call them alkalins. It's just another word. It means the same thing. It means a base. I like to use the word base just because it sounds different than acid. It starts with a different letter. So I tend to call them a base in place of an alkaline, but especially in industry or especially in commercials, you will probably hear the word alkaline in place of the word base. So you need to be aware of both of them. So I've left all of the characteristics of acids up here because now we want to compare those characteristics with that of a base. Again, I'm going to mention a taste to you, but that doesn't mean you should go around tasting everything to decide if it's an acid or a base. That could be very dangerous. So while acids taste very sour, and in fact the vast majority of the foods we eat tend to be acidic in nature, there are some foods that are bases, and those tend to have a very bitter taste to them. Have you ever brushed your teeth with baking soda? If you have ever done that and you know that bitter taste of baking soda, then you know what a base tastes like. Coffee can tend to taste kind of bitter. And so depending on how that coffee has been made, sometimes it's acidic, but sometimes it will have a basic taste as well. If you've ever had unsweetened chocolate, I know that that's one of my very favorite things to get for Christmas. You know, when my husband or my kids will get me something for Christmas, a lot of times one of the things they'll get me is some of that 80 or 90% cacao chocolate. And everybody else looks at me and goes, how can you eat that? That's so bitter. But I'm like, it's kind of an acquired taste. I kind of like it. It's not completely unsweetened. It has a little bit of sugar in it, but when you get up to that 80 or 90% cacao in it, it's got a pretty bitter taste. And so that is a basic food that we eat as well. There are places in nature, just like we find acids in nature, we find bases in nature as well. For example, anytime that we put fertilizer down, a lot of farmers around here will put ammonia on their fields to help the corn grow better. And so that is a fertilizer, that is a base. Your pancreas makes a base in order to keep everything in your body in balance. And so if you're going to be eating all these acids, you got to have something to counteract all those acids. So your body's going to produce a base in that pancreas to help counteract that. So we don't eat nearly as many bases as we do acids, but there are a few that we eat, and you're going to find those types of things in nature as well. We said that acids react with metals, bases may react with metals, but a much more characteristic, something more characteristic of bases is that they feel very, very slippery. And again, that does not mean that you should go around feeling everything to determine if it's an acid or a base, but a lot of the cleaning chemicals that we use, soap, feels very, very slippery. And most of our cleaning supplies are bases. We use bases for that. And so they are going to tend to feel very slippery, very slimy. It's a characteristic of that. We found out that acids conduct electricity because of the fact that they donate hydrogen ions, and we know that electricity tends to flow between hydrogen and between positive and negative ions, and bases will do the same thing. Bases also will conduct electricity. So that is a characteristic of them as well. Acids and bases will both conduct electricity. We said that acids are proton donors, bases are proton acceptors. The donors have to have something to donate to, and so the base tends to be what accepts those protons. Now, how does that work? Let me see if I can show you. Just like, and I've erased that part over here, but you remember yesterday I said that the easiest way to tell if something is an acid is that if it starts with an H, with a hydrogen. Well, the easiest way to tell if something is a base is that it ends with an OH. So something like this, NaOH, OH is called hydroxide. And so hydroxide will actually break apart from the sodium. We saw before that if you had NaCl, we talked about how that breaks up and you have a sodium ion and you have a chloride ion. Well, this will break apart if you put it in water also. So if I put this in water, what I end up with is a sodium ion and a hydroxide ion. So basically the oxygen and the hydrogen are stuck together, they're bonded together, and they take that extra electron that the sodium gave up, and you end up with an OH that has a negative charge on it. So this is called hydroxide. Okay? Now, what happens is that when you put actually both hydroxide ions and hydrogen ions in water, they will react with water. So if I take this OH minus and I get this H plus from over here, look what happens. I have this OH minus, I add the hydrogen ion that came off of my acid. Well, now what do I have? Well, I have a negative and a positive, and those add together and make a 0, right? I have 2 hydrogens and an oxygen. Well, 2 hydrogens and an oxygen makes H2O, doesn't it? Of course it does. And so that's when, and again, we're going to talk a little bit more about neutralization the further we get into the chapter, but that's what we mean when we say that something gets neutralized. The hydroxide from the base and the hydrogen ion from the acid add together and they make water, which isn't either an acid or a base. It's neither one. Okay, so NaOH, that OH right there, if you see an OH in something at the end of a chemical formula, a lot of times that's going to be a base. Something like KOH, there's another OH. This is going to be a base as well. Okay, so I think I said NaOH is light. That's what you find in soap. It feels very, very slippery. Interestingly, I forgot to mention this yesterday, but the other thing that can happen with these hydrogen ions is the hydrogen ions can react with the water molecules that are already there. And so the hydrogen ion will go attach itself to this other water molecule, and it will make H3O with the positive charge on it, and that's called a hydronium ion. I'll put this here so that you can kind of tell that that is actually supposed to go over with this, since I forgot to mention that, okay? So your hydrogen ions react with water and they can make hydronium ions. And then the hydroxide ions that are produced by the base can also react with these hydrogen ions, and then they can make water that way, okay? The last thing, the last characteristic that we want to mention on a base is that it also will change color with an indicator. And in this particular case, again, there are lots of different kinds of indicators that you can use, but the one that I want you to be able to remember, again, is the one with litmus paper. Blue litmus paper comes in 2 colors. It comes in blue and red, and we said that yesterday, blue litmus paper will turn red in the presence of an acid, and so with the base, it happens just the opposite. Red litmus paper will turn blue in the presence of a base. And that's actually, again, kind of why I used a blue marker when I started talking about bases, because red litmus paper will turn blue in the presence of a base. And again, there is a picture in your book. I can't remember what it's a picture of, but I remember there was a picture of, they were showing you that in the presence of a base, they had a piece of red litmus paper and they showed you that it was turning blue. And that's just one example of an indicator. There are all kinds of others, and we'll talk more about them as we go on in our study of acids and bases. So let's kind of look at the comparison between the acids and bases, because I want to make sure you get the characteristics straight. Acids taste sour, bases taste bitter. Okay? Acids react with metals, but bases will feel very, very slippery. Both acids and bases will conduct electricity. Acids are proton donors, but bases are proton acceptors. So recall, here's your hydroxide ion that gets produced when a base ionizes in an aqueous solution, in a solution that has water as its solvent. And so then that OH minus reacts with this H plus to make water. So it has accepted the proton from over here, and it has made water out of it. So here's your proton donor, here's your proton acceptor. And then finally, both acids and bases will change color in the presence of an indicator. There are lots of different indicators, but the specific one I want you to remember is litmus paper. Blue litmus paper will turn red in the presence of an acid. Red litmus paper will turn blue in the presence of a base. So you want to make sure you are able to keep those characteristics of acids and bases straight.